Now, I'll discuss delusion in Cauchy completeness by showing that irrational numbers cannot be expressed by Cauchy sequence. Completeness implies that there are no gaps or missing points in the continuous number line. A completeness axiom has several versions, including Cauchy completeness, which states any real numbers, rational or irrational, is the limit of Cauchy sequence of rational numbers, that is, infinite digit representation of rational numbers. However, Cauchy sequence in digit expression of an irrational number x is close to, but not equal to the irrational number x, which is converged to as the limit. Let's take an example of pi as an irrational number. Pi sub n, which is the truncated decimal expression of pi, is 3, 3.1, 2.14, 3.141, which is 3.0 bar, 3.10 bar, 3.140 bar, 3.1410 bar, Pi sub n for any natural number is a rational number with trailing zeros. Thus, pi sub n cannot be pi, which is an irrational number which cannot have trailing zeros. Some may not be satisfied with this very simple proof. Thus, I'll provide another proof. As in video 1, the definition of Cauchy sequence is if, for every epsilon larger than 0, there exists capital N in natural numbers such that absolute value of x sub m minus x sub n is smaller than epsilon for all m and n larger than capital N, then x sub n converges to a limit x in R, written as x sub n approaches x as n approaches infinity. Then claims that limit x sub n equals x by the proposition that the limit of a converging sequence is unique. However, I show that the limit of a converging sequence is not unique, as in video 1, 2, 3, and 3a, 3b, and 3c. Limit x sub n approaches x but is not equal to x. It is only close to x. The decimal expression of pi is a Cauchy sequence, as you see here. In order for a Cauchy sequence of pi to be unique, thus to be equal to pi, absolute value of pi sub n minus pi sub m needs to be 0. Because pi is an irrational number, all the ith digit between m and n in pi sub n cannot be 0 for all m and n larger than capital N. If all the ith digit between m and n in pi sub n is 0, pi sub n is a rational number pi m sub m with trailing zeros. Minimum absolute value of pi sub n minus pi sub n is when the nth digit in pi sub n is 1 and all the ith digit between m and n in pi sub n is 0. Thus, minimum absolute value is 1 over 10 powered by n minus 1. As in video 8, limit 1 over 10 powered by n is larger than 0. Therefore, even the minimum absolute value is larger than 0. Therefore, Cauchy sequence of pi is not unique, thus is not equal to pi that is converged to as the limit, which can be generalized to any irrational number. Therefore, irrational numbers cannot be expressed in digit expression as a Cauchy sequence of rational numbers. However, it has been wrongly endorsed that irrational numbers can be expressed in digit representation, which deluded to c equals 2 to the power of irrational. The illusion that irrational numbers can be expressed in digit representation erroneously vindicated the paradox of invariance of dimension that will be discussed in the next video 10. That c equals 2 to the power of irrational misled to the erroneous inference that 2 to the power of irrational is larger than irrational. This erroneous inference of 2 to the power of irrational is larger than irrational gives an illusion that Cantor's diagonal argument is correct, because CDA appears to prove 2 to the power of irrational is larger than irrational. That is expected, which will be discussed in video 11. The concept of convergence and limit, Cauchy completeness, and Cantor's diagonal argument are the cornerstones of modern mathematics. However, they are all flawed, but they support each other, making them appear logically consistent. Delusion in the concept of convergence and limit leads to delusion in Cauchy completeness, which leads to delusion in invariance of dimension, which will be discussed in the next video 10. And more importantly, Cauchy completeness is the basis of Cantor's diagonal argument that will be discussed in video 11. And CDA appears to validate Cauchy completeness by proving that C is larger than irrational. Please send critical comments to this address. Thank you very much.